In this class, now I am going to explain you orbital velocity. You know students, around the sun, Earth is revolving in elliptical orbits by rotating itself. See here, sun is there. Around the sun, Earth is revolving in elliptical orbit. You know, Earth is third planet from sun. It is revolving around the sun by rotating itself. Sun is kept at one of the foci of that ellipse, and Earth is revolving in this elliptical orbit by rotating itself. Due to that only day and nights are forming. You know that. And around the Earth there is a gravitational field. Due to this gravitational field only, whichever object if you throw upside in this gravitational field, again it is attracting toward the Earth. So in this gravitational field, we are sending satellites. You know, many satellites are revolving around Earth to do various researches. Every satellite has its own orbit. Around the sun, around the Earth, in the gravitational field, satellites are revolving in the circular path. How these satellites are revolving around the Earth? In the circular path. So the velocity of satellite which revolves around the Earth in circular orbits is known as orbital velocity. Got my point? Sun is there. You know, Earth is a third planet from the sun. Earth revolving around the sun in elliptical orbit. Sun is kept at any one of the foci of an ellipse. How the sun is rotating around the ellipse? By rotating itself. So, up to certain distance on the Earth, there is a gravitational field. In this gravitational field, satellites are rotating, which can be called as geocentric satellites. Every satellite has its own orbit. In their own orbit, satellite is revolving in the circular orbit or circular path. The velocity of that satellite is known as orbital velocity. Now let us find orbital velocity of satellite revolving around this Earth in the circular orbit, which is at a distance h kilometers away from the Earth. So this is satellite, which is revolving around the Earth in this circular orbit, which is at a distance h kilometers or h unit away from the Earth. Mass of the Earth bm, and let us take radius of the Earth to be capital R. You know students, apply the universal law of gravitation between this satellite and the Earth. Here small m is the mass of the satellite, and which is revolving around the circular path, which is at a distance h units away from the Earth, and capital R is the radius of the Earth, and capital M is the mass of the Earth. Now apply the universal law of gravitation between these two. So this is attracting towards the Earth, no? Hence capital F is equal to capital G, capital M, small m by from here to here R, from here to here H. Hence, so here what do you get? R plus H whole square. R plus H whole square. This is what? Here here gravitational force. The satellite is attracting towards the earth. Same like if you throw any object, again it comes toward the earth only. It reaches some height, again it comes toward the earth. But why it is not coming toward the earth? Because it has one more force which is working on it. That is called centripetal force. What it is? Centripetal force. So that centripetal force is F is equal to m v square by r square. Here what is r? So mv square by r plus h you will get. Centripetal force. So in place of this you can write v naught. Okay, which works outside of the orbit. But at the same time, same amount of force is working toward the earth. Both will be equal. So in such case only, so this journey of the satellite in this circular path around the earth is possible. What it is? Centripetal force, you know, mv square by r, but here r value r plus h you have to write. M means mass of the satellite. Okay, here velocity of that satellite I have taken as v naught here, because our aim is to find orbital velocity of satellite. Hence I have written v naught here. mv naught square by r plus h. Here law of gravitation, capital G, capital M, small m by r plus h whole square. Both are equal. This is working toward the earth. This is working outside of orbit. Both are equal in magnitude but opposite in direction. This is working outside, this is working towards. Both are working on the same satellite. Hence, that satellite is revolving around this circular orbit around the earth. Both are equal. Now we equate both of them. If you equate both of them, so here what do you get? M v naught square by r plus h. So which is equal to, see here, capital G, capital M, small m by r plus h whole square. You can write r plus h into r plus h. One of the r plus h is cancelled. One small m cancel. Now what is left? V naught square, which is equal to capital G, capital M by r plus h. What is capital R? Radius of earth. What is small h? Height of the satellite from the earth. Compared to this radius of the earth, h is very negligible, very small. Means here r is very much bigger than h. Hence, so you can neglect it. In place of h, you can keep as 0. So here v naught square, which is equal to capital G, capital M by capital R you will get. You know students, relation between the small g and capital G. So what is that? Small g is equal to capital G, capital M by r square. R square you can write r into r. Take one of the r left side. Gr is equal to capital G, capital M by r you will get. So in place of this gm by r, you can write this gr. Now v naught square, which is equal to, so capital G, capital M, what we have to write? Gm by r, small gr you have to write. Small gr. Now send the square to the right side so that you will get v naught is equal to square root of gr. So this is the orbital velocity of that satellite. Okay, I hope you have understood. Thank you one and all. I am requesting you to subscribe and like and share my channel so that my classes reaches to many people. Thank you.